So next on stage, I'm calling Ms. Valia Eliopoulou. She's the mission leader of the Energy and Resources Management mission in CORE. So Valia, the floor is yours to call your panels.
Thank you. So please join me on the stage. Good afternoon. I'm Valia Eliopoulou. I will be moderating this panel on energy and sustainability of process industries with Industry 4.0. I joined CORE 4 years ago, and for the past a little bit over a year now, I have been leading the Energy and Resource Efficiency unit at the CORE Innovation Center. So to set up a bit the context for this discussion, the European process industry is at the forefront of the European economy, and therefore also at the forefront of the European research and innovation agenda. So today we will talk about enabling Industry 4.0 technologies that help this twin digital and green transition of process industries. We will talk also about the added value they bring to the industries themselves in terms of competitiveness. And we will also touch upon challenges that arise during planning, implementation, and operation of these innovations. So the European process industries, they have come together and formed a partnership, SPIRE, which stands for Sustainable Process Industry through Resource and Energy Efficiency, which is actually fully aligned with the strategic objectives of the European Commission. And this partnership provides a pathway to decouple human well-being from resource consumption and to drive competitiveness, basically. It also aims at integrating, demonstrating, and validating systems and technologies to achieve two key energy and resource efficiency goals. The first one is a reduction of up to 30% of fossil energy intensity compared to current levels. And the second one, a reduction of up to 20% of primary raw material intensity. So I'm very happy to be joined on this panel by a group of esteemed experts. So we have with us Anna Domenic. She is the head of innovation at Celsa Group, a leading multinational steel manufacturer with a strong focus on circularity. Anna leads the initiatives of the group to drive the net positive objectives of the group. We have Mario Pichler. He's leading the international collaboration activities at SCCH, an application-oriented research center in Austria, focusing on software and data science. And Mario is leading the collaborations on twin transition, digital and green transition, and artificial intelligence. We have Sam Zuhara, Professor Sam Zuhara, who is a full professor at the Brunel University of London, also a fellow at the Royal Academy of Engineering in the UK, and he's also chair of thermofluids and head of the thermal management research group at Brunel, with a long list of journal papers, publications, and patents also adopted at multinational companies. And last but not least, we have Georgios Simiklis, who is a senior researcher and research manager at Iceland's group of ICCS, a research center here in Athens, Greece, and he's leading multiple groups of researchers on topics such as earth preservation, circular economy, smart manufacturing, and circular economy. So thank you all for joining me on this discussion today. I'm very pleased that we all are here today. So I would like to open the discussion with some questions to our technology developers first. So novel and radically improved production processes are key to increasing energy, resource, and CO2 efficiency in industrial value chains. So addressing these challenges basically require technologies, products, and processes across the entire value chain. So first question is to you, Mario. So one major goal of the European process industry is to use energy and resources efficiently within existing industrial processes. How can Industry 4.0 technologies, such as advanced process techniques used in Triniflex, for example, Project Triniflex, and combined with digital twins, be leveraged to help reduce or even prevent waste of energy and resources?
Yeah, I hope I can contribute a meaningful answer to that. Because, yes, as a research center for data science and software science, we are also always very interested in figuring out how the impacts of our activities are. And maybe Anna know very well, but in 2027, so in 2 years from now, the Austrian steel making company, voestalpine, they are replacing their coal-based blast furnaces by 2 electric arc furnaces, and with that they can save 4 million tons of CO2 per year, which amounts to 5% of the whole Austrian CO2 emissions in a year. So this is really amazing savings. And when we are doing our data science, software science projects, then we are always also asking ourselves, okay, what kind of contributions could we bring with the technologies that you mentioned? And I think that on different levels there is potential. So we could start by analyzing this question from let's say from a signal processing level, because all the chips and all the things that are driving, so to say, the digital transformation are very important also in the industries that you mentioned. And even, I mean, we are, as a research center, we are working together with the local university, with the Signal Processing Institute there, for instance, and they're currently trying to figure out how they could even improve the most basic operations in a chip level, okay? So let's say multiplications, which are, yeah, amounting to a lot of all the calculations a day in a processing unit. So, and if you could just save some energy there, because of all those millions calculations in a second going on, you can save a lot of energy. And the other interesting thing is, and we are also working in neuromorphic computing, because we have a very energy efficient brain, and if we were able to, so to say, replicate somehow this energy efficiency of our brain, then we could also save a lot of energy. There is a professor at EPFL in Lausanne, for instance, who had an ERC grant on neuromorphic computing, and he was investigating how could he, so to say, transform those brain-based processes to the operation of data centers, because they're also very intensive in such terms. So on a signal processing level, we can save a lot of energy. If we go to the process level of a single industrial plant, so through this process analysis, we can also try, with figuring out what are the causal reasons for kind of things that are using lots of energies. If we can support the process engineers with any kind of answers to those questions, so it's also possible on a process level to save lots of energies and reduce waste. And we could even address it from a value chain perspective for the whole process industry. We have heard about the things about digital product passports supporting circular economy and so on. So also on this level, all these things can assist a lot. Digital twins, we have heard it in the last sessions in the morning already. You can use them for plant planning to increase efficiency and reduce waste. I mean, Jaakko I think it was Jaakko on his slides, he had specifically those 2 words, efficiency and waste, through the utilization of digital twins. So I'd like to stop here for the moment.
Yes, it was very, very good that you broke down in levels, and this is very fascinating about the energy efficiency with the brain. This is a very fascinating idea. Now over to you, Yorgos. Another goal of process industries is to replace current feedstock by integrating novel and renewable feedstock, or even to invent basically new materials and products. And here we introduce concepts like upcycling, recycling, and reusability. And ICCS is now coordinating the first hub for circularity here in Greece, the sales project. Can you explain how Industry 4.0 solutions on digital product passport or advanced material sorting, for example, will be applied in this case, and what benefits they will bring?
Yeah, hello, hi to everyone. At first, it's a great pleasure to be here. I was very happy to see so many familiar faces, and still I see much more from here that I didn't manage to talk during the break. So thanks again, guys, for organizing it and for all the people. So hoping that it will continue next year and even expand in time, so we will have more time to discuss even during breaks or whatever. And then going back to circularity of resources, of course, it's a very important aspect, and of course, it's one of the priorities of Spire. It's among the top priorities also in the Institute, where we do applied research in the field, and we try to see how digital technologies could play a role on that. Building upon what was discussed just before, definitely digital product passports are a common tool which is between the industry and research at this moment. Like, this is already implemented, at least from regulation side, in some industries like batteries or textiles. But we see a lot of interest from both communities, and I think it's a very good opportunity where we can combine this interest and bring already like results from research directly to the field. For example, within the Institute, we are working on the usage of sensing devices and how they could play a role for dynamic updates on the DPPs. Because, of course, it's very important to organize our data, to keep everything there, to have all we need on the products, but the products' characteristics are changing during the lifespan of the products. And this is an aspect that we are using a lot, but also we are trying to see how also all the stakeholders of the value chain could play a role on that. For example, how we could improve the recyclability of materials by engaging the citizens in that, like, for example, with the Right to Repair Directive, and how we could explain to people how to manage the products, and that could lead, of course, to better circularity of materials potentially, as like a lot of materials like end up to the citizens that are using it in the end. And of course, this is also leading to better processing of materials during their value chain, and apart from recycling, and even before reaching recycling, like how we can improve repurposing, repairing, etc., etc. But even if they reach the last steps and the end of life, we are working a lot on how we can improve the recycling through better mechanical separation and sorting, because we have a lot of new materials, we have novel materials, we have materials that even our waste management facilities do not know how to process them. We have materials flowing around the globe, and this is a big issue, like about how to process them and how ready we will be in order to bring them back to life. So within the Institute, we are working on exactly on that, like on a better identification of materials and being able to bring them to work, either at end of life, as I said, like with waste management, but even within the factories and within the same facilities, about how they could reuse within the production value chain. Last but not least, of course, we are trying to apply all of them in Theseus project. It's a very big part of our work the last 2-3 months, as it is really new, but it's also a flagship initiative from Spire, as there are currently established 8 hubs for circularity around Europe, hoping that this will be the 9th in Attica region, where we try to apply all these concepts about circularity of resources, how this can be coupled with energy efficiency and the usage of renewable energy sources within the process industries, which is also a big challenge that we will see coming the next months. And last but not least, we also consider water, which has a double role, either towards recovery of water, but also the coupling with energy.
Lots of research opportunities there, and I guess also opportunities for business modeling, I guess.
Yeah, indeed.
Thank you, George. Okay, and over to you, Sam. So a third goal of the European process industry is to reuse waste streams and energy within and between different sectors, for example, as in the hub for circularity, as Yorgos mentioned. And this includes recovery, recycling, and reuse of post-consumer waste. Can Industry 4.0 be combined with novel technologies for heat recovery, such as heat exchanges, for example, as you do in the project StreamStep? And what improvements can be expected?
Thank you very much. Very wide question. First of all, thank you to Core Innovation for the kind invitation and for the very successful conduction of this amazing meeting. We certainly met many familiar faces, so thank you again. And coming back to your question, if you look at the EU target of carbon neutrality by 2050, and look what we are all doing as researchers, engineers, SMEs, everyone, what are we all doing in order to achieve this by 2050? And with the Commission putting an intermediate target of 55% reduction of the carbon emissions compared to the 90s figure. If you look at that, also look at how we are trying to achieve that intermediate target. Implementing renewable energy sources will not actually get us there. So 100%, we all admitted it and we know it, energy efficiency has to be looked at. Now, just look at the last 2 years since the Ukrainian war started. Many of us just woke up from a very long dream of cheap energy. And suddenly, natural gas, which used to be a very cheap fuel, now is quite expensive. Companies start to pay more attention to how much fuel they use, not only for the carbon emissions aspect, cost. They want to keep their company surviving. So reducing fuel is one way of actually helping companies to continue going. But from our point of view, it helps the EU achieving the target it put on. So energy efficiency is the key, and we all know it. Having said that, there are limitations with technologies that have been implemented and still being implemented. We call them conventional systems. And these limitations are known. This is why we keep seeing stacks with fumes coming out of them, which is something we should all work toward eliminating because they're just waste. That's where advanced heat exchangers comes in. These systems are developed in order to address challenges that other conventional systems couldn't address. Now, where Industry 4 comes in, I can give you one example. For example, in the oil and gas industry, they don't like to be the first to try anything. They like always to see things being proven first, proven twice, proven third times, and then they will think about implementing it. It's not always easy to install something. But listening to the speakers today, of course, knowing how digital twin can be a very powerful tool, the good use of sensors, instrumentations, collecting good data. This good data can then be used in demonstrations that we have in projects. These are small to large demonstrations. Train digital twin, try to replicate scenarios, go to these companies who are afraid of actually trying something new and show them basically using the digital twin tools. If we are to implement this technology in your factory, this is the saving that you will get, which will be the number one target, really, to show how much money you will save. And this is how much carbon you will be basically saving also from emitting to the environment. And that is the direct use of Industry 4 in actually taking something from a trial, from a funded project, or even from other projects, to a new user who will trust basically the output of this tool because they trust the way the data was used. So I believe this is really the most important use of Industry 4 in support of actually implementing novel technologies in areas that are usually quite scared of utilizing them.
Thank you, Sam. And that gives me a good chance to talk about the end user. And you mentioned trust. So a core of Spire is the process industry itself. So the goal is to try to reduce environmental footprint and to drive competitiveness by doing more and or better with less. And this include raw materials, feedstocks, the resource, conversion processes, end user needs, and waste streams. So coming to you now, Anna, as an end user, a multinational steel company, there's a strong innovation focus related to energy, emissions, and circularity. Can you tell us what Industry 4.0 technologies you have tested so far in your innovation projects, and what have you gained from these applications?
Yes, of course. So let me briefly introduce what CELSA is so that you can understand why and how we use these technologies. CELSA is a big European steel recycler which has the particularity that we cover a very big part of the value chain. So in our group, we have the scrap processors, which means that we collect end-of-life products from manufacturing, like end-of-life vehicles or electronic waste, or also from construction. We sort this scrap, and the steel part that comes with it goes to our steel makers. Then we give to our intermediate products a shape in the rolling mills. And finally, we have the final transformation plants, which at the end of this journey provide steel materials to the construction sector and the automotive sector mainly. So it means that only with CELSA Group you can almost close the loop of these two sectors. Also, it's not so particular anymore in Europe because after the Green Deal, all the steel makers are working a lot towards decarbonization, but we also work a lot towards full circularity with this advantage we have of this very big vertical integration. So our sustainability goals are full decarbonization, full circularity, and the innovation strategy is fully aligned with that. In terms of decarbonization, what we do is focusing on reducing the usage of natural gas in the reheating of our product to give it a shape. And for that, digital tools are very useful in terms of simulation. So digital twins are being used to check how our existing furnaces could be using hydrogen in the future. We have European projects funding that. Another approach in which digitalization is very useful for decarbonization is the optimization of the process. So our electrical furnaces, which is the machine in which we melt the scrap, 150 tons every 45 minutes, they consume during 45 minutes, they consume like a city of 150,000 inhabitants. So you can imagine that if every 45 minutes I consume that along the day and I can just optimize it for a 1%, the impact is huge. And machine learning is helping us to do that thanks to the development of models of our electrical furnace. Other areas in which digital tools are helping, you have also mentioned that, is when we work with residues, which are also our main feedstock. In scrap, computer vision is critical because we need to characterize it to know what we are inputting into the furnace, but we also need to see what are the different streams, because we need to sort it correctly in order to give or sell to our clients good aluminium, good copper, because from electronic waste, from electric vehicles, we not only extract steel, we can also sell a lot of very valuable metals. So computer vision is also helping to that. And finally, when it comes to such a large value chain, a digital product passport is, of course, a tool we want to use, and we want to leverage all the efforts we are doing on it in order to have a much better value proposition for our clients. And that means collaborating with our suppliers and with our clients, which are actually the same people. So the OEMs of automotive, they are the ones that are producing the products that then will be scrapped. So it's quite a challenge.
Thank you very much, Anna.
Thank you.
I would love to continue the discussion, but I'll see that our time is up. So I'm keeping some keywords that I heard from you today. So the various levels of energy efficiency that Mario mentioned, the various business models from circularity, the trust that Sam mentioned, and Anna, basically the test beds for simulation, but also the collaboration with the whole supply chain, basically. Thank you all for joining me today. Thank you to the audience for listening. And I would like to give the floor to the third and last panel session for today, the digital transformation of mines with Industry 4.0, and my colleague Konstantina Tsioli, who will moderate. Thank you very much.